right, so if I'm starting with the pre-image A and I'm rotating to A prime, I could rotate clockwise, okay, 90 degrees. I could also rotate counterclockwise, 90, 180, 270. All right, so there's two ways to rotate to get that, okay? And the second one here, if I'm starting with image B and I'm rotating to B prime, okay, I'd be rotating counterclockwise 90 degrees. Okay. However, if I'm starting at B and I'm rotating to B prime, if I rotate it clockwise, 90, 180, 270, okay. Notice how our two numbers always add up to be what? 360, right? So if you rotate right or rotate left, it doesn't matter. You can get back to the same place, but they have to add to 360. And then the third one here, if I'm starting at C and I'm rotating clockwise, okay, I would be rotating 180 degrees to get there. However, if I'm rotating counterclockwise, all right, then again, it'd be 180 degrees. Now, as you move up through classes, like you get the trig, we don't do clockwise, counterclockwise, we call them positive, negative angles, right? So positive angles are clockwise, negative e counter, depending on the context. All right, so here's an example. All right, ABC was rotated to make A prime, B prime, C prime. Okay, it looks like it was rotated clockwise 90 degrees. Okay, if I had rotated it counterclockwise, all right, then it would have had to go 270 degrees to get there. All right, let's make some observations here. Let's complete the table with the image, or the pre-image and the image. Okay, so first, the pre-image, point A is 2, 3. Point B is 5, 8. And point C is 6, 1. So what we're trying to do here, okay, is generalize, like we did before, algebraically, how can we translate these, okay, or excuse me, rotate these to figure out what the new vertices will be. So A prime ends up being 3, negative 2. B prime ends up being 8, negative 5. And C prime ends up being 1, negative 6. Okay, so how does the rotation affect the values in the ordered pairs? So what I want you to notice here is the pattern. Okay, in each of those ordered pairs, the X and Y were flip-flopped. Okay, for a 90-degree rotation, the X and Y were flip-flopped. Okay, and then one of them became negative in each of the three cases. Okay, so which number became negative? Was it the X from the original that became negative for the new? Or was it the Y from the original that became negative for the new? Okay, so if I'm writing this in words, I'm going to say flip X and Y and make X negative. Okay, so when I write the algebraic rule for this, okay, if my original is X comma Y, then my new one is going to be negative Y comma X. No, I got that backwards. Sorry. My new one is going to be Y comma negative X. Wrote it right, said it backwards. Okay, so what I want you to notice there when we go back to the original here is that the Y value stayed the same and became the X value. Okay, however, the X value became a negative, right, and turned into the Y value. Okay, all right, I want you to turn the page. I want you to try a couple of these on your own and see how you do, and then come back for some answers. Go ahead and push pause. All right, so for this next problem here, ABC was rotated 180 degrees clockwise or 180 counterclockwise, give it the same thing. So if I write down my coordinates, okay, for my pre-image, I had 2, 3 for A, 5, 8 for B, and 6, 1 for C. However, my image, I came up with -2, -3, -5, -8, and -6, -1. Now we want to make that observation about the rule. Okay, notice here that the X and Y's did not flip-flop, but they all became negative. All right, so when we make that 180-degree rotation, okay, we don't have to flip the x and the y. Okay, we only have to make them negative. So negative x, negative y would have been my algebraic rule for that one. And when I look at number 6, my image to my pre-image to my image, it looks like I've rotated 270 clockwise or 90 counterclockwise. Okay, they both yield the same image. In my pre-image, okay, my vertices were at the same place, 2, 3, 5, 8, and 6, 1. However, in my image, okay, because it's a 90-degree rotation counterclockwise or 270 clockwise, however you want to view it, I'm going to have to flip my x and y again, okay, but this time I'm going to make that y number negative. Okay, so I want you to notice how I went from 2, 3 to negative 3, 2. So my x number stayed the same, even though it's in a different position. However, my y number became negative. Okay, so I have negative y, comma, x. Describe what would happen if a figure rotated 360. Hopefully you realize that that would be exactly the same. So your algebraic expression would just be xy. Now they're trying to get us to do this and just think about it without a picture. Okay, so if it was rotated clockwise, what I want you to observe here is that anytime your x and y's are flip-flopped, okay, then that means that we're looking at a 90 or a 270-degree rotation. If they stay the same, in the same position at least, then it's a 180-degree rotation. So here they flip-flop. All right, so the other way you can think of this is by just thinking of your quadrants. Okay, so my G is negative x, positive y. So it's in quadrant 2, and the new one ends up in quadrant 1. Okay, so that would have to be a 90-degree rotation clockwise. Okay, which means my y value stays the same and my x value becomes the opposites. Same thing over here, right? Give yourself a little coordinate plane. Okay, write down where the original was. M is in the first quadrant. M prime ends up in the second quadrant. So this is a counterclockwise 90-degree rotation. All right, so what happens to my degree measure, or my angle, or my xy values? Okay, my y flips and becomes negative, and my x stays the same. All right, triangle ABC has the coordinates shown below. Jamie will rotate the triangle using the rule, all right, xy, all right, gets rotated to y negative x. Describe the possible degrees and direction of the rotation. Again, it looks like 90 degrees clockwise here for this one. All right. And then if I list the coordinates of A prime, all I'm going to do is apply that rule to this. So my y value stays the same, negative 1, but my x value flips and becomes the opposite, positive 5. And I could do that for all those. All right. And last here, summarizing rotations and as far as congruency goes. Okay, so rotations always preserve the congruency of a shape. We're not making them bigger or smaller. We already talked about this. Dilations are the only one that do that. The rotations always change the orientation of the figure. The only exception would be is if you rotate it 360 degrees, it would be the exact same. Okay, but in all other cases, the orientation changes. And then rotations will never change the orientation of their vertices. Okay, we're not reflecting or changing the order in which the vertices are listed. Okay, we're just rotating it around the point. All right, hopefully you're able to copy those notes down, and we'll see you in class.